looking at this first table, we have 2.35. If we add 1, we're at 3.35. I multiply that up by 4. I'm like 13 point something. What is it? 13.4. Is that what you guys got? Okay. 13.4. This one I can do in my head easier. 42 plus 1 is 43. Times 4 is 160 plus 12 for 172. Okay. Would someone like to share an integer they used in this function table for an input? Yeah, and say your name again. Vinny. My cousin. 9.7 to start? Wow, that's an interesting choice. Okay. And so then we had 10.7 times 4. So 10.7 times 4 is 40 plus 2.8, 42.8. Okay. And then I want to look in terms of x. I think this is a fun way to think about it. X could be any number. So I would take any number plus 1 and then multiply that by 4. All right? So checking out this next one, we have to recognize that 3/4 is 0.75. That's where we get our 10th place. The 10th place of 2.35 is 3. Of 42, it's 0. Who's got one for me? Oh, I got a fun one. Let's do my fun one. Pi, it's 1. Anybody have one that they want to share that they tried out? Yeah, Lizzie. 2/10? It's 2?
Yeah.
You wrote it as 0.2?
Just 2.
Nice. Cool. All right, we have a couple more of these to check out. So, I'm not going to spend a lot of time on this one. Okay? So, let's divide 1 by the input. So, over here, I'm going to divide 1 by the input, and I get 1. 1 by the input, what do I get here?
0.
Oh, think to the warm-up, y'all. There's no answer. We can't divide by 0, correct?
Yeah.
And then I'm going to call this one, who's got a fun one? Anybody got a fun one to do? 10? No, what do you think? 64. So 1/64. That is kind of fun. I like that. 64 is a nice number. There's a lot of factors, 8s and 2s.
Wait, what's 1 divided by
1/64. Fractions are division. I like to rock fractions for that reason. Cool. This again. What input can you not use with the rule divide 10 by the input and add to 3? What's the number or the input that you cannot use?
0.
Well, okay, let's test that out. Divide 10 by the input added to 3. I can do 10/3. That works. 0 pumps out 10/3. Who's got another guess? Decide. Let's try it. 10 divided by -3 plus 3 is no answer. Because what did that do to the denominator? It slapped that 0 up in there. Can we divide by 0? No. And then, this might not be in your packet. This is just the activity synthesis. And then here's a fun one. Just on a hand. Put it in the air on your hand. How many input-output pairs do you think you need to guess a rule? I'm seeing some 3s. 5s. 1, 2. Here's the challenge with 1. Check this out. If 6 goes in and a 3 comes out, let's say, then it could be divide by 2 or -3. Just 1 wouldn't get us there, right? So I would say at least 2 would be my, yeah. I like that. Or sometimes I'm like, yeah, I can do it in 1, and then I think a little more. I'm like, oh, but 1 could pump out 2 different things. Over this. So, input 0. Divide by 2 is 0 plus 1? 1. 2 divided by 2 is 1 plus 1? 2. -8 divided by 2 is -4 plus 1? 3. 100 divided by 2 is 50. 50 plus 1 is 51. 51. That's how I say it. All right, y'all, let's start with number 1 here. Second lesson. How many numbers are there?
7.
There's 7 numbers there, right? So, any volunteers to help me make a new list with everything square? Yeah. Is it Ava? Ava. Hit me with the numbers.
1, 9, 1, 4, another 9, 16.
Yeah. As I'm looking at this, do I have any repeat numbers now? Yeah, so that repeats and that repeats. So I went from 7 numbers to 5 unique numbers. Right? I guess that 5 would go here. So who can explain to me what happened there? Why did the number of numbers change on my lists? Why did the number of numbers change on my list? Sean?
Because there's 2 numbers, so you only have to have 1.
Yeah, but why did that shake out like that if they were different up here? What happened? So I squared them all, but what did squaring them all do? Okay, so you're on the right track with something there, right?
It made the negative positive.
Yeah, it made everything positive, right? Notice our new list here? Everything's positive. And the reason for that is, no matter what my number is, if I square it, anything times itself is positive, right? Because negative times negative or positive times positive. So it made me have fewer answers, or fewer in my set. This is, in math, they call this a set, okay? It's pretty cool, huh? Just cool to think about. So this is kind of challenging to think of. Any other rules where we could have different inputs result in the same output? I can think of 2. Should I take the easier of the? I'll take the harder of the 2. Anything to the 0 power except 0. Those all result in 1. I get more than one thing. Multiply by 0, let's check it out. 6 times 0 is 0. Negative pi times 0 is 0. Smiley face times 0 is 0. Cool. It does that. So do you think these are functions? I had a number, I apply a rule to it, and I get an output. No matter how many times I throw 3 into that function, is it pumping out 1? Yeah. No matter how many times I throw negative pi into that function, is it pumping out 0? It's always pumping out one thing. Real quick, raise your hand if you weren't 100% on that something to the 0 power equals 1. Be honest. Anybody would anybody guess 0? Okay, here's.
The 0 power is 0.
Yeah, so I'm going to prove it to you real quick, okay? Sidestep from the lesson. 2 cubed is 2, 4, 8, right? 2 squared is 4. 2 to the first is 2. Everybody good with those?
Yeah.
What's happening to my answer over and over?
It's getting lower than dividing by 2.
Dividing by 2. So my next answer would have to be 1. 2 divided by 2 is 1. So 3, 2, 1 for my exponents. My next exponent would have to be 0. So if you ever forget, just set up a little experiment. Test it out, right? Kind of cool to see that, isn't it? All we did was extend patterns. I love that little proof. Cool. So there are circumstances where it'll pump out 2 of the same answers. Okay. Got a couple blank sides. So this isn't in your stuff. Let's just look at this together. Okay. So a person's 60 inches tall. Can we get to the height in feet? Would we have enough information to form a rule to pump out feet? Okay. What would you have to do?
Well, you divide by 12, but then if there's a remainder, then you have to do something with that.
Then you have to mess with that. It has to be feet and inches, or you go to a weird decimal where you had to divide by 12. Yeah, so 60 inches is 5 feet, right? Right? So that is a function. I can apply a rule to that. So what you're going to practice doing next is you're going to look at a bunch of situations, and you need to say yes or no. Can there be an input-output diagram drawn for that situation? If it's a yes, I want you to draw it. Take 3 to 5 here. A person's 5.5 feet tall. Can we get their height in inches? Yeah, and what would we do? Yeah, I'm not going to write out the whole thing just because I don't have room on here. But times 12 would get us there. There is a rule to get us there. A number is 5. Do we know it's square?
Yeah.
Yeah, it'd be, square it. I'm going to write x squared. That's the rule. Square your input. In this case, it's 25 and only 25. The square of a number is 16. Do we know the number?
4.
Here's the actual answer, and let's talk about it. So 4 times 4 is 16. Is there another way? It could be -4 times -4. So if we just know that a number squared is 16, there's 2 potential answers for that, meaning we don't know which one it is. It could be 4 or -4. So that one is not. That one has 2 outputs. You guys follow on that?
Yeah.
Because I can get to 16 with a 4 or a -4. So I don't know which number it is because there's 2 different ones it could be.
Wait, when it says do you know the number, does it mean like the middle square? Like does it say like does it mean like do you know the rule or do you know like the output?
So if it's saying this, so we know the output, the square of a number. We don't know the input here, right? Can we get to the number that squared is 16? Just one answer?
Oh.
You could say yes and say 4 and I'd be like, nope, it's -4. Right? So because there's 2 different outputs for that. How about this? A square has a perimeter of 12 centimeters. Do we know its area?
Yes.
Yeah. So what's unique about a square and its side lengths? They're all the same, which means it has side lengths of 3. So I would square a side length, right?
But the rule would be divide by 4 and then square that.
Yeah, I like that. Let's write that rule. So I'd take a number, I'd divide by 4, and I'd square it. That'd be the rule. Divide by 4 and square. You're going to always see me write division as a fraction pretty much if you're not used to that. Right? But what about a rectangle? Do I know length and width for sure of a rectangle with just the perimeter? No, there could be lots of combinations. So this one's a no. That could be lots of things. If you're given a number, my slide's missing a 1/5 right here. If you're given a number, can you find something that's 1/5 as big?
Yes.
Yes. And the rule would be something like x times 1/5 or x divided by 5. Those would be the same thing. Okay. And you're given a number. Do you know it's a reciprocal? Always, yes. Okay. Reciprocal means you flip it. The technical math definition of the reciprocal is what can you multiply a number by to equal 1? If you flip the number, it gives you a number you can multiply that number by to equal 1 every time. Okay? So reciprocal is the flip. When we're dividing fractions, we multiply by the reciprocal. All right, that's a fun one. Guess which number is my favorite? Number 3. I like that one. I like number 3 for some reason. All right. So, we're good here. We're good here. We just talked about that. It comes back. I think we're pretty good. This is just saying, we're going to summarize here next slide, everything we were just doing. So, each time we put into a function, and this comes from the first lesson too, one thing goes in. Uh-oh, I wasn't on the draw thing yet. Nope. A number goes into a function, right? How many things should come out if it's a function? One item, right? Don't write this down, we're just summarizing. So if it's a function, one thing came out. But we had some times where more than one thing came out, right? Like I had 16 go in, and we take the square root of it, and it pumps out a 4 and a -4. So guess what? That's not a function. Functions will only have one thing pop out. That's how we're going to summarize all that stuff with could we make it happen or could we not make it happen, okay? What about a circle? If you know the circumference, can you always find the radius of a circle?
Yes.
Yeah, because circumference is 2 pi r, right? Or pi d. You can always get there. What about this third one? This one's kind of silly. A person's age is 14. What's their height? Can you use someone's age to get their height?
No.
Nope. It's always different. It's so variable, right? So that is not a function. So now we know a function is a rule with exactly one output. It can be the same output as other things, but each input can only have one output. And if we know that a rule has exactly one output for each allowable input, then it depends on the input. So notice that word depends. We're going to be dealing with independent variables coming up, okay? Because we're going to move into tables next. Cool. You've got to cool down. Let me tell you your homework as well. So start working on that cool down.